we talk about progress in AI, but what we see is progress in statistics. I haven't seen anything uh, that has gotten one step closer to being able to create knowledge in the machine.
Welcome back to the Gen Z Diplomat podcast. My name is Aish Prakash. I'm very excited for this episode because it's our first guest on this podcast. His name is Bryant Cruse, and he's the CEO of New Sapiens. Bryant has founded 3 AI companies, 2 of which have been acquired, and New Sapiens is his third. Bryant has also worked at NASA and is a student of philosophy, specifically epistemology, and you'll see how his engineering side and his philosophical side commingle as he's explaining certain concepts to you. I really enjoyed this episode with Bryant, and I hope to talk to him many times in the future. As always, this is the Gen Z Diplomat podcast. Please support it by subscribing to the channel and adding it to your favorite podcatcher. And now, I bring you Bryant Cruse.
So, what did you accomplish on the missions operations team for the Hubble telescope?
Well, my primary job when I started there was on the mission operations contract, which were the group that flies, actually controls the spacecraft. Not that took the instruments or did the observations. They were up at Johns Hopkins, but we actually flew it, as we said. We controlled the vehicle, made it do what it had to do from the control center there in Greenbelt. And I was specifically in charge of the management of the data, all the data management equipment, the recorders, and the computers. That was my specialty. And I trained the people who sat on the consoles for the data management system,
Right.
how to interpret the telemetry, and I was the first one to actually put together a full command load
Oh, really?
of all the commands that would have to be executed in order to do an observation. So I prototyped that for the first time. We found some problems in the way it had been scaled, and we had to devise different workarounds and different operational scenarios to operate the vehicle as designed from what it was originally intended. That kind of question doesn't really get asked until you get further down the road. This was still before launch, of course.
Really?
Okay.
Really?
Yeah, we were
And
still figuring it out.
so in our previous call, we were talking about there was this moment at NASA where it clicked for you. Could you say more about that in terms of the way it clicked for you and thinking about artificial intelligence and knowledge?
Yes. So I had come out prior to becoming a space systems engineer. I'd been a Navy pilot and flown big airplanes and spent a lot of time in the cockpit. And so when I walked into the mission operations control center to, quote, instead of flying an aircraft, flying a spacecraft, I said, wait a minute, this is all wrong. This is like a science project. You have people looking at engineering numbers on screens and trying to evaluate in real time what those numbers mean. And now you had to look at 4 different telemetry parameters to figure out whether the battery was being discharged or recharged. I mean, and I thought this is no way to do that. And by this time, I had studied and trained, and I knew what the telemetry meant, and I knew what I wanted to see on those consoles, on the screens. I wanted to see things like I saw in the cockpit of a C-130, status lights, and big gauges telling me what state the systems were in, and instead of all these numbers. So I knew what the numbers meant because I'd studied. I'd had the expertise. I was a space systems engineer, so I had the knowledge. I had the knowledge of how the system worked and what it looked like inside and all the interfaces. I had the knowledge in my mind. And I thought, how can I get that knowledge into the ground system computers and let them do all the real-time conversion of data into information and low-level information into high-level operational, actionable information? How
Right.
can we do that in a computer? So that was it. That got me thinking. That kind of became a mission, a personal mission for me for the next 15 years of my life.
And so was that leading you directly to artificial intelligence, or was there kind of like a step to AI?
I'd say a very brief step,
Okay.
and that I went to the ground system computer programmers,
Okay.
and I said, "Well, this is what I want. This is what I want the software to do." And they looked at me like I was crazy, and they said, "Well, that would take thousands of lines of code, and we don't understand what those numbers mean. We don't have the expertise, and there's no budget for it, and there's no charge number for it, and so have a nice day. So,
Right.
so that was that. So I said, well, what else is out there? And so the year now was like 1985, and
Okay.
rule-based expert systems were the big thing. They were the rage. They were AI, and
Right.
they had a similar level of hype and excitement about expert systems at that time as machine learning does today. And though I was on a NASA contract, and that was my customer, I was an employee of Lockheed Missiles and Space Company. And they had, like a lot of companies at that time, they were investing heavily in AI, and they'd set up an AI center out in Palo Alto,
Mhm.
just up the road from Stanford. And so I contacted them, and I said, this is the problem I have. And they said, wow, that's really relevant to our company, because they were kind of more theoretical.
Right.
And so they were interested in that. And well, we do have an expert system shell, which was an environment by which you could try to capture your knowledge and convert it into rules, and then those rules could be processed in a program.
Right. Right.
Of course, that's what they consider AI to be. And so I was able to borrow this shell, and but it turned out that it was too slow to keep up with the telemetry. It took up too much. All of these expert system shells, as I call them, or inference engines, were very computer intensive for the computers of the day. And in
Right.
fact, there was a big industry at that point of building special machines called Lisp machines to
Okay.
process a Lisp language
Right.
that would be faster. But NASA didn't use them. They used faxes. And so that was what I had to work with. So I got involved with the guys at the AI Center, and I spearheaded a project to build a real-time expert system shell. And they thought this would be a good thing that would run on faxes. But the challenges, and along the way, I got NASA kind of interested in this and excited about it. And at the same time, Lockheed had set up the first what they called a residency program. And that
Okay.
was designed to bring engineers from around the company into their AI center for 6 months and get what would be equivalent, both practical and academic training, mostly from Stanford professors down the road, which would be equivalent to an MS degree in AI.
Fascinating.
I said,
Fascinating.
send me, and they did.
Yeah.
And NASA paid for it. And while I was there, I worked with those guys to outline this new real-time expert system shell. And the real challenge was the expert system inference engine part was well understood. But because of how the load it put on the processor, we had to put the user interface on a separate computer and the data interface to telemetry on a separate computer. So we needed 3 computers.
Right.
And this was like before there was inter-process communication software. This is before the internet. This is before any of that stuff. There was just the hardware Ethernet spec, so you
Right.
could send data. So a lot of the effort we went into was building inter-process data exchange software, so to get the architecture work. And then I went off and built an expert system to analyze Hubble telemetry.
And
And
so,
yeah.
no, please.
So everybody patted me on the back that this is cool,
Yeah.
but nobody really knew what to do with it. There was still no
Right.
charge numbers for it, and there was still no requirement for it. NASA liked it, and I got to meet the VPs at Lockheed, and they said, "You have a great future, young man," all that stuff. But nobody was doing anything to use it.
Right. Right.
So I
So
was in
since
my reserve squadron one day and complaining to one of my uh, fellow pilots who happened to be an investment banker in New York in real life. And he said, well, why don't you guys start your own company and commercialize it yourself? And I was there like, you can do that? So I ended up being an entrepreneur as well as an AI guy. And we started a company to do that. But again, we did some interesting demos, but we pretty quickly found out that the technology just didn't scale. It took too many rules, and the rules were hard to manage. And it became pretty evident. I was always a bit skeptical that at AI school they taught me, well, that's how we really think. We have all these rules and we're not conscious about it, but that's how
right.
we do all this stuff. And I remember sitting on the console watching the numbers flip back and forth at the Hubble Control Center and saying, I'm not applying rules, I'm recognizing patterns. But in any case, the problem there was, you tried to represent knowledge, one rule at a time, like one fact at a time. And the number of facts is, as you put them all together, they're infinite in number. So it can never scale. There's no structure there.
Right.
You can only structure a line of reasoning to do one thing. It's like learning how to tell time by reasoning how a clock should work. So it didn't scale.
So since you've been in this space since 1985, at least you've been thinking about these problems since 1985. The fact that computers don't have, let's call it intrinsic knowledge of what they're doing. They're just computing. So you've been thinking about AI since 1985 up until now. So how has your interpretation of it changed throughout the trajectory of your career? Can you trace back like certain points where your thinking has evolved, or how have you interpreted AI since 1985 up until now?
Well, it really goes back longer than that. It really goes back to, the early 70s when I was a student studying philosophy and epistemology and coming up with some ideas about what knowledge was, and my practical experience with Hubble, really focused on it's about putting knowledge in the machine. So I was always focused on that. And over the years, though, it became, and with expert systems, those two ideas didn't seem that far apart. They called it knowledge-based systems. They call it knowledge representation. But over the years, I came to realize knowledge, and based on going back to my earlier speculations in philosophy, that knowledge isn't a bunch of facts. And knowledge is not something you represent in symbols. That took me actually a long time to really figure that out. But I diverged farther and farther away with the idea that knowledge and symbols were one and the same, or were dependent on one another. And so the first big wave of AI with expert systems was called knowledge-based systems or symbolic AI. And that's still, considered an alternative. There are people out there right now who are saying, well, we're never going to overcome the limitations of the current wave of AI, which is connectionist or machine learning, unless we combine it with symbolic AI. Gary Marcus, if is a big advocate of that. And Lacan kept saying, no, neural networks can do it all. But I was already off that track. And so I realized I diverged further and further from the mainstream, both from symbolic AI, because we finally realized that what we could do was not symbols,
Right.
but a direct information structure, which was itself not a representation of knowledge, but was in fact knowledge.
Right.
And then I realized that it was just knowledge in the machine instead of a different kind of information processor, but it was knowledge of the same sort. It wasn't a representation, or it wasn't composed of symbols. We didn't really get to that too much later. But the other thing which became evident further and farther along, I frankly was quite surprised that our approach, which we pioneered in my second company, with building a model, that knowledge is a model, and we found a way to put a model of the spacecraft into the computer, which was, again, very limited from what we're doing now at New Sapiens, but was still a model.
Right.
And that jived eventually with my notions of what knowledge was, going back to my philosophical conjectures, that knowledge, in fact, is a model. And then a model is a very different thing, than a bunch of facts.
Right.
So, but I thought that seemed like a pretty straightforward thing. And it was funny, I went to the first conference on artificial general intelligence, and I started going into the singularity conferences every year. But this was in the mid to late 2010s, and realized everybody completely gone over to, it's all about artificial neural networks, and it's all about statistics. And at the first AGI conference, all I heard was statistics, and there were no demos. Okay, and there was no roadmap or speculations about how doing these things with statistical algorithms against large data sets was actually going to ever get to the kind of knowledge that you need in a machine to have the kind of AI we've always been trying to reach, right?
Sure.
So it was only very recently that I realized that the whole approach was different, and that AI is really what you should call imitation intelligence, in the sense that the very beginning of it, at the Dartmouth conference in '56, the language of that was, this conference is based on the conjecture that any feature of intelligence, meaning natural human intelligence, can be duplicated in a computer. So it's always been about trying to look at some aspect of what we think is going on in our head and trying to do that in a computer and hope we'll get the same results.
And that works as a brilliant segue into New Sapiens. So this is the third AI company you've been a part of.
Mm-hmm.
And so at first, I guess we'll start with what is the difference between New Sapiens and the previous two AI companies that you've been a part of?
Well, again, the first were really designed to be aerospace companies. I mean, my second company is called Altair Aerospace, and we're particularly focused on automating and changing the way spacecraft were operated. And
Okay.
AI was a tool to do that.
Mhm.
The first one tried to use traditional symbolic AI, and we failed. And the second one, we pioneered the idea of models. And key to models was the idea that you could look at your own knowledge and decompose it into a very clear model. In that case, it was of systems, states, and subsystems, which engineers do naturally in that environment. So we pioneered the key, kind of one of the key things. We developed a methodology and editors by which you could specify your knowledge as a model. In this case, it was just a finite state model of the computer, but the core concept was there. So, but it was very focused. It was really about data, telemetry data into actionable states that you could display, or you could automate the analysis of the telemetry. And we actually went out and built a launch control system. We were an aerospace company. We built control systems for satellites. So it was very much an engineering company, but we pioneered this very, very powerful and really cool technology to do that, and it worked. We didn't call it AI though, interestingly enough, and the reason
What'd you
is,
call it?
well, we called it finite state modeling, or automated, telemetry analysis automation. And the reason is that symbolic AI had crashed so spectacularly in the early '90s that AI had become a dirty word.
Interesting. Okay.
If you said AI, you lost all credibility because everybody knew that was just a bunch of hype and hoax. Everybody got their fingers burned, investing in symbolics machines and
Yeah.
things like that. And so you couldn't say it that. But
Right.
certainly it was knowledge in machines, but it was very rigid and narrow and really only designed to apply to kind of one area. So it wasn't general. And so the third company came about after my first two companies eventually sold. I had some time and a little bit of money, and for basically 10 or 15 years, I combined my philosophical insights about the nature of knowledge with my practical experience automating spacecraft and building models and putting them into machines, with the thought that why can't we generalize the model? Instead of having a model of a spacecraft, why can't you have a model of the everyday general common sense world? Now that sounds hard, and it is hard. I think it's so hard that, and without the philosophical insights and the practical experience I'd already had, I think people who go down that road just go, I
Right.
don't know what to do. So they go back to something they do know how to do. And today that's machine learning.
So for you, AI can't just be an engineering problem. You have to combine certain aspects of philosophy into that in order to get, you know, that let's call it knowledge of understanding or understanding of knowledge. Um,
Yes.
so this your third company, New Sapiens, what does it bring to a maturing field like artificial intelligence? Because from my perspective, I just recently started learning about AI. I say recently, it was back in 2020,
Mhm.
but I started
Well, you
learning
learn
about
fast. You learn fast.
to each their own. But I've started learning about social media, the way AI is used in social media. I started learning about, the advancements in robotics, self-driving cars, and then, we touched upon the singularity. Dr. Ben Goertzel and philosophers like Nick Bostrom talk about, super intelligence and how to get to artificial general intelligence. But then when you and I were talking, you were saying some very, very interesting things about New Sapiens and how you're using narrow intelligence, defined as just like for example, the social media algorithms we work with, like the YouTube algorithm, are narrow intelligence, just for people that don't know. So you're using narrow intelligence to solve the problem of knowledge. How does that work? Could you expand more on that?
Well, I'm not sure when you say we're using narrow intelligence. We are certainly, in terms of processing the model, we are using conventional software techniques, the algorithms that we have understood how to put in computers all the time. Now, in
Right.
that context, it hasn't been called intelligence, but in
Okay.
fact, if you do look at it, and again, so much of these kind of conversations are semantic in nature. So
Okay.
let's say, okay, so intelligence, we say, is how is a process is made up or composed of processes that process information, and from that they build models of the world. Because I
Okay.
think any definition of artificial intelligence, uh, other than just using it as a term, but from the notion of what we mean and all get excited about AI, it all ends up building models of the world and putting them into the machine. And that's not just me. I have direct quotes. I often quote Jan LeCun saying exactly that same thing, and also admitting that they don't know how to do it. He said the
Okay.
piece that we don't have is how to build machines that have knowledge, models of the world and common sense. He said we don't know how to do that.
Okay.
He believes that they'll figure it out, but he hasn't provided a roadmap. So that's what intelligence is. So the intelligent part is the information processing. So if we look into our own minds, and you talk about from a narrow, the narrow algorithms, we already know about inference. We know about abstraction, synthesis, analysis, memory management. Those are what you might call the processes of intelligence. And you could say, well, that's narrow. And it is narrow because it doesn't become general until you can use those processes to process general knowledge. So by that thing, all of that narrow intelligence processes already, the computers already have that, right? So by that notion, they're already intelligent, but they're ignorant, right? They have
Intelligent but
they,
ignorant.
they have no knowledge, and they don't know how to create knowledge.
Right.
Now, what the artificial neural networks folks are trying to do to get there is the problem they're trying to tackle is to basically build neural network structures that will build knowledge kind of out of whole cloth, the way the human brain, or the way the human brain seems to do too when a child is born, and and it's not born with common sense knowledge of the world, but we don't know what it's born with actually, but we see them acquire knowledge in the first 5 years of life.
Right.
So I think on the basis of that, on the basis that as we understand the human brain to be a neural network, then we suppose or imagine or conjecture that it would be possible to build a similar neural network in a machine and have it proceed the same way. That's horrendously difficult.
Right.
And no one that I see has made. We talk about progress in AI, but what we see is progress in statistics. I haven't seen anything that has gotten one step closer to being able to create knowledge in the machine out of whole cloth. But it turns out there's a different way. So, and that's what we're doing at New Sapiens, and why we've diverged entirely, as we see, from the entire enterprise of AI, of emulating natural intelligence. And that is, we said, well, we're not going to do that. Instead, we're going to go right to the end goal, which is to get that knowledge structure, that special information structure, which is a model of the world, that is a model of the world as can be encompassed by the human mind, Okay, because that's what we're doing here, right? We're not trying to create some knowledge we don't understand.
Right.
It's the knowledge we do understand, and we're trying to get a computer to have that. So what we've essentially done is, instead of trying to build the whole thing from scratch and have it from scratch learn how to look around itself and start creating ideas and models of the world, we've kind of found a way to take an image of that common sense world out of the human brain and transplant it directly into the computer. So we call that
Fascinating.
synthetic knowledge. And that's, the idea of synthetic intelligence as opposed to imitation intelligence. Again,
Yeah.
like a natural diamond versus synthetic diamonds. They're both equally diamonds, right? Because they both have the exact crystal lattice structure. One created by nature, one created by an engineered process. It's an entirely different process.
Right. Right.
Didn't require giant continents in each other, in a giant planet compressing things over millions of years. You can do it in the lab much more cheaply. That's what we've
And
done.
so at New Sapiens, you're building a product called Sapiens. And
Sapiens. Mm-hmm.
in our previous talk, you used an example of the cute little yellow bird. I would love to go back to that, just how it pro or how it. I feel like using even the word process is incorrect when talking about Sapiens, but how it. But let's just use that word. How it processes that, please.
Well, it has to go back to the notion, what does it mean to have a model of the world in there, right?
Okay.
And so in order to do that, which I said at first blush, if you don't have the philosophy and haven't had the background, haven't had all this experience, you wouldn't know where to start. Well, we did kind of know where to start and studying what a model is. And say a model airplane. Models, by the way, it's one of those fundamental concepts, and that you can't really define it in terms of words referring to simpler concepts, and you put them together to get you can define an airplane that way, right? Machine
Right.
that flies, but you can't describe a model that way. It's fundamental. You can only give examples of it. So here's a model airplane, here's a model ship, here's a model something else, and you abstract what's common to all of them. So, I know what a model is. Okay, there's a prototype out there, and there's a model about it, which recapitulates a lot of the same features. So knowledge is a model of the world. It recapitulates a lot of the same features and functions, relationships that the world itself has, but in a totally different implementation, as it were, or structure. So if you're going to do that, if you're going to build a model of an airplane, you have to know what an airplane is and what it looks like and its features. Well, how do you approach that in terms of the whole world?
Right.
And the way you do that is you say, well, if I look at my model of the world, it's composed of individual concepts and ideas, as what we call them, which are themselves sub-models, and then they all have connections to other, and the whole thing is a big structure. So if I wanted to figure out how to build one of those, I first need to take some and realize that the more complex ones are made out of simpler ones, right? So
Right.
you start breaking them down into smaller ones and smaller ones and smaller ones. And finally, you get to the ones where you really can't break them down anymore. So they're like the atoms of thought. So then if you have the atoms, can you then classify them in such a way that you kind of know a priori how they'll fit together, just because which atoms you've got there? And then how the larger structures, the molecule ideas, how they will interact based on their structure and their properties as knowledge. So the property would be knowledge properties or meta knowledge properties. So you have to figure out what all those are. And so that's what we've done. And so, one of the major structures that we realize that we have to deal with is the fact that as we talk about things in language and communicate with language, we don't make distinctions about these things, but they're there. And one of the largest, the four biggest categorizations that you can talk about is the difference when we talk about our ideas or knowledge of things as we conjecture they exist independently of us. And then there is a level or a layer or a classification structure category of things that exist as an interaction between our perceptual capabilities and those things that are perceptible. And then there is a whole nother area of ideas and concepts that we use every day, which describe how we emotionally or subjectively respond to those things which we perceive or think about. And then finally, it's the intellectual part of it. What is our intellectual assessment, theory, knowledge, ideas about all of the above? So if I say to my Sapiens, I say, do you know what a canary is? He says, no. What is a canary, boss? And I say, well, it's a cute little yellow bird. So how does it put that together? It just like a human decoding language, and the words are pointers to ideas that it needs to already know about. Some of them
Right.
are more connected things like is, and some of them more direct references like bird and yellow and pretty and little. So it looks each of those up and finds they're classified. They according to where they fit in that structure. Okay, that overall structure, that categorization. Imagine, if you will, kind of like the periodic table of the elements, but for ideas. Okay, so what is it? So the bird is something that is understood to exist, whether we think about them or not. So that's down in this category. That is, as a structure, as an idea to hang other ideas and relationships on. The little is a property of the bird, which is quantitative. Okay, a quantitative property, and then that's been modeled to say in that context, little would mean reference to other birds. So that is an actual property of the bird itself. But the yellow, it understands, is defined as a perception. So the perception then is an interaction between some property of the bird and our human perceptive organs. So it would know, as we model it out, that, well, it's only yellow in the daytime, as
Right.
far as you talk about yellow as a perception, because that's what the perception is modeled to be. Okay, and so it knows, quote, knows the difference between the thing in the world by itself that stimulates the yellow, which is a frequency of radiation coming out from the bird, which again is related to some emissivity and absorption, reflectivity properties of the bird, which are things that exist in themselves, and then our perception of it. But finally, cute is a subjective experience. Okay, it's something a person feels. So even though the grammar says that it's a property of the bird in the same sense as little or yellow, which are not in the same sense either, because
Right.
little is a quantitative inherent property, we might call it intrinsic property, although relative. It's a relative intrinsic property.
Right.
See, we start to classify all these things.
Absolutely.
Whereas yellow is an extrinsic, that relative property that requires the interaction of something other than the thing itself. It requires something to perceive it. And cute, beyond that, is subjective, which is only applicable or can only result in or imply the presence of a sentient being. And
Right.
so when it puts it all together, it models all the structure, so that when I come back and say, okay, Sapiens, now, what is canary? And it will say, it's a little yellow bird. You think they're cute.
I love that. I love that. It's fascinating to think that a computer can understand that. But I guess that's precisely why you're down this road. We
Yes.
are a little pressed for time according to Zoom, but
Already? Okay.
already, yeah, it flies fast when you're having fun. But I wanted to ask you, so someone like myself who's interested in AI but doesn't really know where to start, from your perspective, where should they begin? Should they start, like, from my perspective, just reading it, trying to understand it? Should they, get an internship? What would you recommend the path they go down?
Well, the most important thing is to decide what you mean by AI and why you are interested in it. Okay, because there's a great quote I'm about to put on social media from a professor at Berkeley. No, this is at Sheffield, who said, he was talking about, we should have never called language models. We should have called them language sequence models. And he said, this is a problem, because they're not models of language. They're only
Right.
modeling how the words get sequenced. And he said, this is a problem that you have when you name an algorithm, or for that matter, a whole pursuit, on the goal, as
Right.
opposed to what it actually does. Okay, so in terms of what it actually, so now we have machine learning. Okay, so what it actually does is it's really good at pulling out statistical patterns from your large data sets, right? But we call it AI because that's because a lot of people hope that it will be the key and the path to get to AI. Like Jan
Right.
LeCun, he believes you can get to AI. So he's doing that. He's naming it what he's trying to achieve in terms of what it does. So now it depends on if you're interested in what you mean by it. If you mean by it, machines that have knowledge and can think and are going to make all those changes in the society and the world that we hope they will make, then you got to decide whether you think machine learning is on that path or not, or whether there's some other way to get to that goal. For instance,
Right.
what we've done at New Sapiens. Now, if you're interested in solving problems like folding protein molecules or being able to find the data representations or data extract data patterns and plasma fields and a tokamak, machine learning is a powerful tool for that.
Mm-hmm.
Okay. And if that's what you're interested in, if you're interested in statistics, that's the way to go. Or the problems that statistics can solve
Right.
or solve well. Now, I think we're using them like we would use AI, and that's a problem. So
Sure.
you ask yourself what you mean by AI. Then
Perfect.
if you're looking for knowledge in the machine, study that.
Study that. Beautiful, very eloquently put. Brian, I very much enjoyed this conversation. I think the work you're doing and have done is fascinating. And I think that New Sapiens and Sapiens can bring something very valuable, very unique, and something very novel to the world. I think there
So
is
too.
unprecedented power in AI that understands us and understands the knowledge that we comprehend on a daily basis. And the fact that we can um, have computers as like have those sapiens as assistants, I think is going to change the world. So I want to thank you for this conversation today, and I hope we can talk very, very soon.
I do too, Yushin. Thank you very much for the opportunity here today.
Thanks for listening to the Gen Z Diplomat podcast. As always, to support it, please subscribe to the channel and add it to your favorite podcatcher. Of course, please follow us on other social platforms like TikTok, Twitter, and Instagram. Leave a comment to let us know what your favorite part of the podcast was. And once again, thank you very much to Bryant Cruse for being a part of this episode. I firmly believe that the more we talk about what future we want, the more likely we are to build a future that we need. Thank you for listening to this episode, and I hope to see you next time.